Hello everyone. Today we are going to see vector calculus and complex variable. Some 2 marks we are going to see in this session. So first of all, first unit, vector differentiation. First question, a temperature at a point x, y, z in space is given by T of x, y, z equal to x square plus y square plus z square. A mosquito is located at 1, 1, 2, decides to fly in such a direction that it gets pulled faster. Find the direction in which it should fly. So here the value of x, y, z has given. We need to find the value of direction, that is del t we need to find. So first of all, I am taking the t value as x square plus y square plus z square, and del t we know the formula of gradient, that is I vector dou t by dou x plus j vector dou t by dou y plus k vector dou t by dou z. So this is integration differentiation of t with respect to x, so that I get only 2x for I vector, next 2y for j vector and 2z for k vector. Now they have given the point as 1, 1, 1. I am going to substitute instead of x, y, z. X takes the value as 1, y takes the value as 1 and z takes the value as 2. So that I get 2i vector plus 2j vector plus 2 times 2 is 4k vector. So mosquito will fly in the direction of maximum rate of decrease, which is 2i vector plus 2j vector plus 4k vector. Our second problem is, what direction from the point 3, 1, minus 2 is the directional derivative of pi equal x square y square z power 4 maximum. Find also the magnitude of the maximum. Here they have given the pi value as x square y square z power 4. We need to find the directional derivative. So the directional derivative means we need to and also find the magnitude of maximum, which means we need to find modulus del pi. So del pi, first of all we know the gradient value I vector dou pi by dou x plus j vector dou pi by dou y plus k vector dou pi by dou z. If I differentiate pi with respect to x, means I get 2x into y square into z power 4 I vector. Next differentiate pi with respect to y, I get 2y x square into z power 4. Next differentiate pi with respect to z, so 4x square y square z cube into k vector. Now they have given the 3 points, which is a directional derivative. So x takes the value as 3, y take the value as 1 and z takes the value as minus 2. If I substitute all the value and multiply it, I get 96 I vector plus 288 j vector minus 288 k vector. So we need to find the magnitude of the maximum, which is modulus del pi. So modulus del pi value is nothing but square root of x square plus y square plus z square. Here x takes the value 96, y is 288 and z is minus 288. If I square all the term and take the square root, I will get the answer 480.45. So the directional derivative is maximum in the direction del pi and the magnitude of this maximum is 418.45. Next, third question. Prove that del of r power n equal n r power n minus 2 into r vector. First of all, I am going to write for del r power n. So instead of I, j, k, I am simply writing it as summation I vector 2 by 2x of r power n. So integrate, differentiate r power n with respect to x, I get n r power n minus 1 into 2r by 2x. So there is I vector before it, just substitute I vector here. We know the value for 2r by 2x is x by r. So there is r in the numerator and also r in the denominator. Bring this r to the numerator so that I get I vector n r power n minus 1 is already there. See, if I bring the denominator to numerator, I can write minus 1 again into x. So minus 1 will become minus 2. Now I am expanding these terms, n r power n minus 2 xi vector. So I am expanding the summation, that is xi vector plus yj vector plus zk vector, which is nothing but the value of r vector. Here I proved the right hand side which is asked in the question. Our next problem is find the directional derivative of pi equal to x, y, z at 1, 1, 1. Here they have given the point 1, 1 in the direction of I vector plus j vector plus k vector. So directional derivative formula is nothing but del pi into a vector by modulus a vector. So direction is in the question denoting a vector, so which assumes the value I vector plus j vector plus k vector. We need to find del pi and modulus a vector. So first of all I am taking the pi as x, y, z. We know the formula of del pi equal I vector tau pi by tau x plus j vector tau pi by tau y plus k vector tau pi by tau z. So first of all going to differentiate pi with respect to x. So x will become 1. So I get y z I vector. Then if I differentiate pi with respect to y, y will become 1. So I get x z j vector. If I differentiate pi with respect to z, z will become 1. So that I get x y into k vector. So now I am going to substitute the point 1, 1, 1 for all x, y, z, so that I get the value I vector plus j vector plus k vector. So given, so this value as a vector I am going to write modulus a vector, which means square root of x square plus y square plus z square. So each takes the value 1. All the 1 square is 1. If I add all the term, I get the value of a vector is modulus a vector is root 3. Now I am going to substitute everything in the directional derivative formula, that is del pi into a vector by modulus a vector. So del pi, which assumes the value I vector plus j vector. So this term del pi plus k vector, and the value of a vector which is given in the question is I vector plus j vector plus k vector, and the value of modulus a vector is nothing but square root 3. So now I am going to multiply each I vector, j vector and k vector which has the coefficient 1, so that I get 1 plus 1 plus 1 divided by root 3, that is 3 by root 3. 3 can be written as root 3 into root 3. There is a denominator root 3 which will cancel each other. So I will remain with the value root 3. So here is the answer for the directional derivative. Our next problem is, what is the greatest rate of increase of pi equal xyz square at 1, 0, 3. So here they are asking for greatest rate of increase, which is nothing but to find modulus del pi. So first we need to find del pi, then modulus del pi. So del pi we know the formula I vector tau pi by tau x plus j vector tau pi by tau y plus k vector tau pi by tau z. First of all differentiate pi with respect to x, x will become 1. So we get y z square I vector. Next differentiate pi with respect to y, y will become 1. We get x z square j vector. Next differentiate pi with respect to z, we get 2xy into z k vector. There is a point given in the question as 1, 0, 3. Instead of x, y, z, substitute 1, 0, 3 and simplify it. I get only the j vector, because I vector will become 0 and k vector will become 0. So the 3 square value is 9, that is 9 j vector. Thus we find the value of del pi. We need to find the greatest rate of increase, which means we need to find the modulus del pi. So square root of 9 square, square and square root cancel each other. So my answer is 9. Next question. Find alpha such that f vector equal x plus 3y I vector plus y minus 2z j vector plus x plus alpha z k vector is solenoidal. Solenoidal means we need to prove del f equals 0 is the formula for solenoidal. So given, I am taking the given value of f vector in the question. Solenoidal means del f equals 0. So I am expanding del dou f by dou x, dou f by dou y plus dou f by dou z equals 0. So differentiate f with respect to x. Wait a minute. Differentiate f with respect to x. I get the value of x will become 1. Next, differentiate y. Differentiate f with respect to y. I get only 1 because there is a y here. And differentiate f with respect to z. I get the alpha value alone. So I get 1 plus 1 plus alpha. So the value of alpha equal to minus 2. The next question we need to prove if a and b vector are irrotational. Irrotational denoting the cross value, solenoidal denoting dot value. Then prove that a vector cross b vector is solenoidal. So given that a vector and b vector are irrotational, which means a assumes the formula del cross a vector equals 0 and b assumes the formula del cross b vector equal to 0. Now I need to show that the a vector cross b vector is solenoidal. So del of a vector cross b vector, the formula is del cross a vector into b vector minus del cross b vector into a vector. So the value of del cross a vector is 0 and the value of del cross b vector is 0, so that I get the value as 0. So hence we can say that a vector cross b vector is solenoidal because the formula for the solenoidal is del f equals 0. So our final answer is 0. So easily say that the given a vector cross b vector is solenoidal. Our next 2 mark is prove that curl of gradient pi equals 0. So first of all I am taking gradient pi, then I will substitute it with curl. Gradient pi is nothing but del pi. We know the formula for del pi, that is I vector dou pi by dou x plus j vector dou pi by dou y plus k vector dou pi by dou z. Now I am multiplying curl into gradient pi. Here also del into del pi. So cross, so that is curl, which assumes the formula modulus I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. Next dou f, this is f1 value, f2 value, f3 value. So here is f1, here is f2 and here is f3. Dou pi by dou x, dou pi by dou y, dou pi by dou z. We need to expand this matrix value. So if I differentiate it, we get all the value as 0. So we can easily say that curl of gradient pi equal 0. Our next thing is prove that f vector equal to y z I vector zx j vector plus xy k vector is irrotational. Irrotational means del cross pi equals 0. So we know the formula for del cross pi, that is I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, and the f1 value is yz, f2 value is zx and f3 value is xy. If I expand all the term which equals 0, first we need to differentiate this with respect to y. I get and differentiate this with respect to z. Similarly all the term, so it will become cancel each other of all the term. I get 0 I vector plus 0 j vector plus 0 k vector which is equal to 0. Our next problem is a fluid motion is given by v vector is equal to y plus z of I vector plus z plus x of j vector plus x plus y of k vector. Is this motion irrotational? We need to show that del cross f vector should equal to 0. Then we can easily say that the given motion is irrotational. Let's find it out. Del cross f vector equals 0, which takes the formula I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, and the value of f1 is y plus z and the value of f2 is z plus x and the value of f3 is x plus y. If I expand it and solve it, I get the value as 0 I vector, 0 j vector plus 0 k vector equal to 0. Thus I find del cross f vector is equal to 0. Hence v vector is irrotational. In vector calculus and complex variable, we are moving to the second unit, that is vector integration. So important 2 marks are given here. So first 2 mark is if f vector equal x square I vector plus xy square j vector. Evaluate the line integral double integral c f vector dot dr vector from 0, 0 to 1, 1 along the path y is equal to x. So we need to find the line integral. So given y is equal to x, differentiate it, we get dy is equal to dx. And also given f vector equal to x square I vector plus xy square j vector. We already know that dr vector is nothing but dx I vector plus dy j vector. So dr vector is nothing but f vector dr vector. Next, dx I vector is nothing but x square into dx, because in the f vector I am comparing f vector multiplying both the thing, f vector dr vector, that is x square into dx, xy square into dy. Next, we already know that the value of y equals x. I am changing this y square as x square. So x into x square will become x cube. I need to find the integral f vector dr vector, which assumes the value from 0 to 1. So f vector into dr vector is given, we found it here, x square plus x cube into dx. So x square, if we integrate x square, we get x cube by 3 plus x power 4 by 4 to the limit 0 to 1. Upper limit only applicable. I get 1 by 3 plus 1 by 4. So multiply the denominator, 4 3s are 12. Next, cross multiply it, I get 4 plus 3, which equals 7 by 1. So this is the answer to find for the line integral. Our second problem is show that the given f vector is conservative vector field, which means if the cross, that is irrotational, is equal to 0, we say that the term is conservative. If f vector is conservative, then del cross f vector equals 0. Okay, this is the rule. If suppose I am taking the vice versa of the concept, del cross f vector equal to 0 I vector plus 0 j vector plus 0 k vector, which equals 0. So I can easily say that the given f vector is conservative vector field. Next, the important definition, that is to state the Stokes theorem. The surface integral of the normal component of a curl of a vector function f vector over an surface S is equal to the line integral of the tangential component f vector around the closed curve C bounding x. So this is the formula for the Stokes theorem. Integral C f vector dr vector equal double integral s del cross f into n cap ds. Next definition is Green's theorem. So Green's theorem formula is integral c u dx plus v dy equal double integral r tau v by tau x minus tau u by tau y into dx dy. Here u, v, tau v by tau x, tau u by tau y are continuous and single valued function in the region are enclosed by the curve C. Now our next definition is proved by Green's theorem that the area bounded by a simple closed curve C is 1 by 2 integral C x dy minus y dx. We already know the Green's theorem formula, integral C u dx plus v dy equal to double integral r tau v by tau x tau u by tau y into dx dy. We need to find tau v by tau x and tau u by tau y. Here the value of v is nothing but x by 2 and the value of u is nothing but y by 2. So that is minus y by 2. In this differentiate v with respect to x, I get 1 by 2. Next differentiate u with respect to y, I get minus 1 by 2. Now substitute every value in the Green's theorem formula. I get x by 2 dy minus y by 2 dy equal to double integral r. So the value of tau v by tau x is 1 by 2. Next tau u by tau value is minus 1 by 2. There is already minus inside the formula. So minus into minus will become plus into dx dy. So half plus half is nothing but 1. So our answer is double integral r dx dy. Next we need to state Gauss divergence theorem. So Gauss divergence theorem states that the surface integral, so this is the formula, double integral S f vector dot n cap ds equal to triple integral V del dot f vector into dv. Next we need to state the Gauss divergence theorem, that is f dot n cap ds equal del dot f vector into dv. So here f denoting a vector function, f denoting a vector function under a closed surface S, and V denoting the volume, that is a volume integral of the divergence f vector taken throughout the volume. Next we are going to see in problem in Gauss divergence theorem. So using Gauss divergence theorem, prove that double integral S r vector dot n cap ds is equal to 3v. So we need to take the left hand side and have to prove the right hand side for a closed surface. We know the Gauss divergence theorem, that is double integral S f vector dot n cap ds equal to triple integral v del dot f vector into dv. Here I am taking f vector equal r vector. So my formula will become r vector dot n cap and del dot r vector into dv. My left hand, right hand side will become for del dot r vector. So del, which assumes the value of gradient I vector rho by 2x plus j vector rho by 2y plus k vector rho by 2z, and the value of r vector is xi vector plus yj vector plus zk vector into dv. So I am multiplying the I vector, j vector and k vector. I get rho by 2x of x plus rho by 2y of y plus rho by 2z of z into dv. So differentiate x with respect to x, which assumes 1, this also 1, this also 1. So I get 3 into dv. So take 3 out. So I get triple integral v. If I integrate dv, I get v. So my final answer is double integral S r vector dot n cap ds is equal to 3v. Next problem is show that double integral S curl f vector dot n cap ds is equal 0 whereas is any closed surface. So we need to take the left hand side and to prove the right hand side. So we know the Gauss divergence theorem formula here, where V is the volume of the closed surface. Since so this is the known condition, del dot curl f vector equal to 0, we get triple integral v del, instead of f I am writing curl f vector. So here they have given the question curl f vector into dv equals 0. So I can easily say that curl f vector into n cap ds is equal to 0. So I am changing the left hand side into right hand side and getting the answer as 0. My next problem is evaluate integral c yz I vector plus xz j vector plus yxy k vector. We need to evaluate it. C is the boundary of a surface S. Here we are using the Stokes theorem because f vector assumes the integral value, single integral value. We know the formula for Stokes theorem. Integral C f vector dot dr vector equal double integral S del cross f vector into n cap ds. Also, we know the value for the curl vector equals 0. So del cross f vector assumes the value as 0. So my right hand side will become 0. So I easily say that the left hand side also equal to 0. That is integral C f vector dot dr vector is equals 0. Next we are moving to the next problem. Using Green's theorem, evaluate integral C x dy minus y dx, where C is the circle, x square plus y square equal to 1 in the xy plane. So we are using the Green's theorem as they asked me using Green's theorem. We know the formula for Green's theorem. Integral u dx plus v dy is equal to double integral r tau v by 2x minus 2v by 2y into dx dy. Here v assumes the value minus y and u, this is a u dx plus v dy, which I am changing it. So v assumes the value x and u assumes the value minus y. If we differentiate v with respect to x, I get 1. Differentiate u with respect to y, I get minus 1. Substitute all the value in the Green's theorem formula. I get integral c x dy minus y dx equal to double integral r. So the value is nothing but 1 minus into minus plus 1. So that is 2 dx dy. So 2 is a constant. I am taking it out. So double integral r dx dy, which is nothing but the area of the circle, which is denoted as y. So I can easily find that integral c x dy minus y dx as 2y. Now we are moving to the third unit, that is analytic functions. We are seeing the 2 marks in analytic function. So the first 2 mark is state the necessary and sufficient condition for f of z to be analytic in Cartesian coordinates. So the necessary condition for the Cartesian coordinate is nothing but f of z is equal to u of x comma y plus iv of x comma y. Here this is Cauchy-Riemann equation. Tau u by tau x equal to tau v by tau y, and tau v by tau x equal to minus tau u by tau y. This can also be written as ux equal to vy and vx equal to minus uy. This is the necessary condition for the Cartesian coordinate. Next, sufficient condition for the Cartesian coordinate is the same Cauchy-Riemann equation. If the partial derivative are all continuous in D and our Cauchy equation, then the function f of z is said to be analytic in the domain D. Our second problem is state the Cauchy-Riemann equation in polar coordinates. So polar coordinate means it will take the value z equal to r e power I theta. Here r denoting modulus and theta denoting argument. Our CR equation in polar form is tau u by tau r equal to 1 by r into tau v by tau theta. Next, tau v by tau r is equal to minus 1 by r tau u by tau theta. Now we are moving to the next problem. Verify whether w equal to sin x cos hy plus I cos x sin hy is analytic or not. So analytic is nothing but if it satisfies the Cauchy-Riemann equation, we say that the given equation is analytic. So first of all, I am writing the given equation. So w assumes the values u plus iv. So u takes the real part, that is sin x cos hy, and v takes the imaginary part cos x into sin hy. Now I am going to differentiate u with respect to x. So sin x alone will change as cos x. Here I am changing x, differentiate v with respect to x. Cos x will become minus sin x. Now I am going to differentiate u with respect to y. Cos hy will become sin hy, and differentiate v with respect to y. I get sin hy will become cos hy. So now I am comparing whether ux is equal to vy. Yes, both are equal, cos x into cos hy, and see whether uy equal minus vx. Yes, it is equal. So the value of vx is minus sin x sin hy minus into uy value is sin x into sin hy. Yes, all the Riemann conditions are satisfied. Hence the given problem is analytic. Now state 2 properties of analytic function. The real and imaginary part of an analytic function satisfies the Laplace equation in 2 dimension. Second condition is an analytic function with the constant modulus is constant. Fifth problem is check whether w equal to z bar is analytic everywhere. So first of all, f of z value is z bar. So z bar takes the value x plus iy. We know that f of z is equal to u plus iv. So u assumes the real term x and v assumes the imaginary term. So z value is x plus iy. So z bar value is x minus iy. So v assumes the value minus y. Differentiate u with respect to x, I get 1. Differentiate u with respect to y, I get 0. Differentiate v with respect to x, we get 0. Differentiate v with respect to y, I get minus 1. Now I am going to check whether it is satisfying Cauchy-Riemann condition or not. Then only I can say that the given term is analytic or not. So first of all, ux equal Vy is the formula. Here ux is taking the value 1 and Vy taking the value minus 1. So both the terms are not equal. So Cauchy-Riemann condition is not satisfied. Hence f of z is equal to z bar is not analytic. So I can easily say that the given term w equal to z bar is. Our next problem is, if f of z is analytic, show that f of z is constant if real part of f of z is constant. So I am taking f of z value as analytic and show that the real part of f of z is constant. So first of all, u is equal to a. So differentiate u. Assumes the value 0. Differentiate u with respect to y is equal to 0. Now f dash of z, the formula is tau u by tau x plus I tau v by tau x. The value of tau u by tau x remains the same plus I. Tau v by tau x value is nothing but minus tau u by tau y. So here I am assuming the Cauchy-Riemann equation. So both the value is 0. So I can easily say that f dash of z is 0. So Cauchy-Riemann equation is satisfying. So easily say that f of z is constant. Our next question, show that the function x power 4 minus 6x square y square plus y power 4 is harmonic. To prove u is harmonic, so first of all I am taking the given function as u. Differentiate u with respect to x, I get 4x cube minus 12x y square. Similarly again differentiate it, I get 4 3s are 12 x square, x will become 1, so I get 12 y square. Next differentiate u with respect to y, so this value is 0. This value will become minus 12 x square y plus 4x cube. I differentiate it again with respect to y will become 1, so I get minus 12 x square. So this cube will become 4 3s are 12 y square. Now I am going to add both the terms. So harmonic meaning is nothing but uxx plus uyy equal to 0. Similarly for the v term, so I am going to check whether the given term is 0 or not. So I am taking the formula tau square. So this is can also be written as tau square u by tau x square plus tau square u by tau y square. So adding all the term tau this and this, so 12x square minus 12y square, this is minus 12x square plus 12y square, plus and minus term, minus and plus term cancel each other, so my final answer is 0. So therefore the given u is a harmonic. Next we are moving to the next problem. Examine whether the function xy square can be real part of an analytic function. So I am taking the given function as u, so that is u equal to xy square. Analytic is nothing but can be real part of an analytic function, which means it should satisfy Cauchy-Riemann condition. First of all, differentiate u with respect to x, I get y square. Differentiate again u with respect to x, there is no x, so it will become 0. Now differentiate u with respect to y, I get 2y xy. Again differentiate it with respect to y, I get 2x. So add both the uxx and uyy, I get 2x, which is not equal to 0. Hence I can say that given function cannot be the real part of an analytic function. The next example is given example such that u and v are harmonic but u plus iv is not analytic. So for that I am taking u equal to x square minus y square and v value as minus y by x square plus y square. So next problem, find the value of m if u value is given as harmonic, which means the formula is tau square u by tau x square plus tau square u by tau y square equals 0. So given the u value as 2x square minus m square plus 3x square, first we need to find the value of x, that is tau u differentiate u with respect to x, I get 4x. Again differentiate u with respect to x, I get 4 alone. So this is here. Next, differentiate u with respect to y, I get minus 2m y. Differentiate u again with respect to y will become 1, I get minus 2m. Now I am adding uxx plus uyy, that is 4 minus 2m equals 0. So bring this 2m to the next side and bring this 2 to the next side, it will become divided by 2. So my answer of m equals 2. Now we are moving to the fourth unit, that is mapping of complex function. So define conformal mapping. A conformal mapping, a transformation that preserves angle between every pair of curves through a point both in magnitude and sense is said to be conformal mapping. Conformal means it assumes both magnitude and direction. If it is isogonal means it is in magnitude but altered in direction. So this is the differentiation between conformal and isogonal. Here is the problem given. Find the image of the circle mod z equal to 3 under the transformation w equal to 2z. So w equal to 2z, I am taking this. So the value of w is u plus iv and the value of z is x plus yi. I am comparing the real and imaginary term. U assumes the value 2x and v takes the value 2y. So x value is u by 2 and y value is v by 2. So already given the circle term mod z equal 3. Z takes the value x plus iy. So modulus means square root of x square plus y square equal 3. So I am taking square root to the next side. So it will become 3 square, that is the value 9. The value of x is nothing but u by 2, that is u by 2 square, and the value of y is v by 2. So v by 2 the whole square equal to 9. So this can be written as u square by 4 plus v square by 4 equal 9. So taking 4 to the next side. So 4 9s are 36. So my answer is u square plus v square equal 36. We are moving to the next problem. Find the critical point of the transformation w square equal to z minus alpha, z minus beta. So I am taking the given value and to find the critical points. So differentiate w with respect to z, I get 0, and differentiate z with respect to w. These are the two conditions which will satisfy the critical points. Now I am going to differentiate 1 with respect to z. So this value is denoted as 1. Differentiate with respect to z, I get 2w. dw by dz equal to z minus alpha into z minus beta. So multiply it inside. So I get 2z minus alpha plus beta. First of all, I am taking dw by dz equal to 0. My left hand side will become 0. So my right hand side will become 2z minus alpha minus beta equal to 0. Bring this alpha minus beta to the next side. So this is alpha plus beta. So I get plus alpha plus beta. Bring this 2 to the next side, I get z value as alpha plus beta by 2. Now dz by dw is assumes the value reciprocal of the given term, that is w divided by z minus alpha plus beta by 2. Now I am taking dz value as 0. So the term right hand side will become 0. So I am substituting w value as 0, then z minus alpha, z minus beta is 0. So both assumes the value z minus alpha equals 0 and z minus beta equals 0. Bring alpha to the next side. So I get z value as alpha and beta. So these are the critical point. Already we found alpha plus beta by 2. Here we found two critical points, that is alpha comma beta. Next problem is find the critical points for the transformation w equal to 2 by z. I am taking w equal to 2 by z. So critical means it should satisfy dw by dz equal to 0. So differentiation of w with respect to z, I get 2 minus 2 by z square equal to 0. Bring this z square to the next side, I get minus 2 equal 0, which is impossible. Actually it is given as wrong. So actually this is impossible term. We are moving to the next problem. Find the invariant point of the bilinear transformation w equal to 1 plus z divided by 1 minus z. So I am taking the term as z equal to 1 plus z by 1 minus z, because bilinear transformation I am substituting w equal to z. So bring this 1 by z to the next side and multiply with z. I get z minus z square equal 1 plus z. So that plus z and plus z cancel each other. So z square value as minus 1. So z value is plus or minus I. Which means the square root of minus 1 is plus or minus I. So z assumes two value, that is plus I and minus I. Next, write the cross ratio of the point z1, z2, z3, z4. So this is the cross ratio of the point z1 minus z2, z3 minus z4 divided by z2 minus z3 into z4 minus z1. Next, define bilinear transformation. The transformation az plus b divided by cz plus d, which also assume ad minus bc should not equal to 0. Then it is said to be the bilinear transformation. Okay, thank you all for the patience listening. Thank you.